This is the Integrated Math 2 Chapter 13 test review continued. So we are going to continue with number 58. So here we go. The directions are asking us to determine the roots of the equation by completing the square. Write your answers in exact simplified radical form. Now, just keep in mind this part B is going to be optional, and part C is going to be optional. They'll be taught in Integrated Math 3, but optional for tomorrow's assessment. Let's take a look at A. If we're going to determine these roots, well, if I'm going to complete the square, that means I want this side to be a perfect square trinomial. And as you can see, it is not a perfect square trinomial at all. The number, this term here, -1, is preventing it from being a perfect square trinomial. So I'm going to take that -1 and move it. I now have x squared plus 4x, and I'm going to intentionally leave some space is equal to 1. Now you'll notice that I have this leading coefficient equal to 1, and that is really great. Okay, that means right here, to complete this square, I can take this middle term and take half of it. Well, 4 cut in half, 4 divided by 2 squared, that's what we're going to do right there. Well, that's going to be 2 squared, which is 4. So I have to add 4 to this side, but then I have to keep things in check and balance, so I better add 4 over here. We all know that this perfect square trinomial now can be factored into a binomial squared. This will become x plus 2 all squared is equal to 5. And at this point, we are going to undo squaring by taking the square root of each side. I have x plus 2 is equal to plus or minus root 5. We will then subtract 2. We're going to isolate that x variable. So we have x now is equal to, and we write the -2 first. This is going to be plus or minus root 5. There are both of your roots for part A. Let's move on to part B. Part B, very, very similar here, but you'll notice we've got to move this -3. Okay, it's not a perfect square, so let's move it out. We're going to try to make this a perfect square trinomial. So we're going to move that. Let's add 3. Add 3. I now have 2x squared plus 8x, and then this is going to be equal to 3. Now, right here, this 2, I would like this to be a 1 right here. Well, the only way to do that is I'm going to have to just divide by 2. So if I divide by 2, divide by 2, and divide by 2, this becomes x squared plus 4x, and I'm going to intentionally leave some space is equal to 3 halves. Now, at this point, I have this leading coefficient of 1, so that gives me the right to divide the middle term in half and square it. Well, 4 cut in half is 2, squared is 4, so I'm going to add 4 here, and then I can add 4 here. We can factor this into a binomial squared. We will get x plus 2 all squared is equal to, well, we need common denominators, so this is going to be 3 halves plus, how about 8 halves? So we have x plus 2 squared is equal to, well, 8 and 3, that's going to be 11 halves. And what we can do right now is take the square root. We can take the square root. We have x plus 2 is equal to plus or minus radical 11 halves. Now, in some cases, you might want to rationalize this, but we're just going to leave it alone for now. We learned how to rationalize already in Integrated Math 1 and in Integrated Math 2. But we've got to get this x alone, so let's subtract 2. And we're left with x is now equal to -2 plus or minus the square root of 11 halves. And you may leave it like that. Those are the two roots that we have found. Okay, next one, part C. Same type of thing. We're going to add 1 to each side. I have 3x squared plus 2x, and that's equal to 1. Well, you'll notice that I do not have a leading coefficient. How about right here? I want that to be a 1, so I'm going to divide by 3. Divide by 3, and divide by 3. We have now 3x, this is going to be x squared plus 2/3 x is equal to 1/3. Now you have to be careful here. It gets a little intense fraction-wise, so why don't I do this for our sake? Let me zoom in a bit. Come on over. All right. So what I'm going to do is I need to recognize that this is a 1 here. So that means I can take 2/3, I can cut it in half, and then what I can do is square that. That's going to be equal to, well, 2 over 2 cancel, and that's 1/3 squared. That's going to be 1/9. So this is the value that I need to complete the square. So that has to be added onto both sides. So let's do that. I have x squared plus 2/3 x plus 1/9 is equal to 1/3 plus 1/9. And now what I have here, you have to recognize that this is actually a perfect square trinomial. And when we factor this, it's going to actually become, let me clean this up, it's going to become a binomial squared. So here we go. X plus 1/3 all squared is equal to, you'll notice I have to get common denominators here. So this is going to be times 3 times 3. And essentially this is going to be 3/9 plus 1/9. That's going to be 4/9. I then take the square root of each side. And it's going to work out pretty nice. I have x plus 1/3, and that's going to be equal to, and plus or minus, well, the square root of 4 is 2, square root of 9, 3, so this is going to be 2/3. We're going to subtract a third on each side. And I have x is now equal to, this is going to be -1/3 plus or minus 2/3. And we have two things happening here. We can separate it into two problems. This could be x is equal to -1/3 plus 2/3, and x is equal to -1/3 and then minus 2/3. So over here we're going to get 1/3, and x is equal to -3/3, or x is equal to -1. And there are your roots. So I think we have satisfied all the instructions. All right. We have found all of our answers, and they're in simplified radical form. Next problem, number 59. All right, so let's take a look. This problem is asking, says Hunter and Hannah completed the square to determine the solutions of this. Now, remember, since this is not equal to 1, all right, this problem is going to be optional. It says, their work is shown below. Which student is correct? Explain your reason. Well, as we kind of go down through here, let's see if we can find some mistakes. let's follow, how about Hunter's work first. So we start off seeing that is a trinomial. You'll notice what we did was Hunter set 0 equal to y, correct? He substituted y and 0 in for y. Then it looks like he moved the 8 over. All right, everything looks good so far. And next, here, let me change up this color here. Next, what it looks like we did is we added 25 to each side. Now let's see what happens here. So from this step to this step, what Hunter did, he added 25. Well, I can see kind of what he did. He took this 10, he divided it by 2, and squared it, which would be 5 squared, and that's 25. The only problem is you may only use this rule, this little strategy on completing the square, if the leading coefficient is equal to 1. Well, look, this leading coefficient here, it's not equal to 1. So Hunter would have had to divide by 2 and then start completing the square. So this is where he went wrong. He forgot to divide by 2 before completing the square. All right. And Hannah, if we look over at Hannah's, all of this looks correct. Look right here, she divided by 2, and now we have 5 halves. You might want to see this. Here's our 5, and this is our 1, so we can complete the square. 5 halves squared, well, that's going to be 25 fourths, and that's what we want to add on both sides. Aha! And you can see we added that on both sides. That works perfect. And then it became a binomial square that looks great. And we got common denominators and added. So it looks like Hannah did this correctly. Great. Okay, next. All right, number 60. I believe that we made this one optional also, because I did include possibilities when a does not equal 1. So here goes. It says, when completing the square to solve this, you need to add b over 2 squared to both sides of the equation only when a is equal to, well, everyone better know this, it should be 1. Okay, so if I had 0 is equal to 1x squared plus bx, then in order to complete the square, right, you would have to, this would be x squared plus bx plus, and this would be b over 2 all squared, and you would have to add that onto the other side as well. All right. And the second part, let's underline this with green. If a does not equal 1, you need to add what to both sides of the equation? Well, let's separate this. So let's just say this is going to be 0 is equal to ax squared plus bx. Well, if I divide by a, I think that you can see that this is going to be 0 is equal to x squared plus b over a x. And essentially, now that we have this leading coefficient of 1, so all we have to do is we're going to take this b over a, we're going to cut it in half, and then we're going to square it. Now simplify this just a little bit. This is going to be b over 2a and all squared. So that's what we can do. We can add b over 2a all squared. Number 61. This one states, this is a projectile motion problem. It says, Mr. Lockray throws a pass from a 2-story building with a vertical velocity of 64 feet per second from a height of 32 feet. Here's your formula. You remember that from chapter 12. It says, write an equation to model the situation. All right. So how about we do this? We've got h at t is equal to negative 16 t squared plus, well, initial velocity. That's going to be, this is going to be your v sub 0. And then we have our 32. That's going to be h sub 0. So that really just means the height at time equals 0. And then if we move over here, this is the velocity at time equals 0, initial velocity. So we'll add here 32. All right. Now, what we have, they're asking us another question here. They're asking us, when will the ball reach the ground? Leave your answer in exact form. And that means simplified radical form. Okay, so we've got to start, we're going to try to find the time t when the height, or h at t, is equal to 0, because when it's on the ground, that means the height is equal to 0. So this is when it's on the ground. All right. So here's what we're going to do. Let me rewrite this formula for a moment. We have h at t is equal to negative 16 t squared plus 64t plus 32. Show you exactly what we're going to do. So for h of 0, h at t, we're going to let it equal 0 because this indicates the height on the ground. Okay. This is going to be equal to negative 16 t squared plus 64t plus 32. Now, you can probably see what we're about to do. We have to solve for t. That's our goal. Solve for t. So we're going to find that unknown time. Now, I don't know about you, but I can see possibly a GCF to pull out. Let's try to go ahead and do that. All right, so let's go with 0 is equal to, how about you think we can maybe factor out a negative 16? That might work nice. All right, so right here, the negative 16s create a 1. So this is going to be t squared plus, and then right here, that's going to be 4, but a negative 4, right? Negative 4. Let's just make this all negative 4t. And then finally, 32 divided by negative 16, that's minus 2. Okay, so you can kind of see now that this entire thing, well, looks to me like our leading coefficient is 1. And that's good news. One problem might be that this negative 2, if I wanted to complete the square, this negative 2 is not a perfect square, so why don't we move it to the other side for now? Okay, so I'm going to add 2, add 2. I now have 2 is equal to t squared minus 4t. Now I'm going to complete the square. So I've got to add things to both sides of this thing. Half of 4 is 2, squared is 4, so we're going to add 4, add 4. I have now 6 is equal to, well, this is going to become a binomial squared, so t minus 2 squared. And you guys know from here, all you have to do is take a square root of each side. And we're going to get that t is equal to plus or minus root 6. Okay, and then actually this is t minus 2 is equal to plus or minus root 6. If I add 2 to each side, I'm going to have 2 plus or minus root 6 is equal to t. All right. So I wanted to show you two things here. You'll notice that I calculated these with the calculator. And 2 minus root 6 is going to be a negative. And then 2 plus root 6 is going to be a positive 4.44. So this value here really doesn't make sense in context of the problem. We're not going to have negative time, okay? So negative time, that's not going to happen in this kind of problem. So essentially we have time is approximately going to be 4.45 seconds. And the question asks us to leave it in exact form. So we would actually have to write it t is equal to, not approximate, equal to 2 plus root 6. All right, let's move on. Here is number 62. We have a parking lot problem. Okay, let's read through this. It says a parking lot that is a rectangle 150 feet long by 110 feet wide is to have its area doubled by adding the same distance x to the length and the width. And then what's the value of x? Well, first we have a rectangular parking lot. I think we can draw that. That might be easy enough. So here is our rectangle. Okay. Maybe about right there. It says we have 150 feet and by 110 feet. And it says the area is going to be doubled. Well, I wonder what that area is there. Well, if we were to multiply that out, this is going to be 110 multiplied by 150, and that's going to be 16,500 square feet. So now we want it doubled. So if I take this calculator again, if we double that, so times 2, that's what we want. Okay, let's take that out. We'll keep that in mind over to the side here. All right, I want to highlight something very important. It's saying here that we are going to add the same distance x to the length and the width. All right, so here's what we're going to do. How about I run along this. This is the length. So I'm going to add some more to this. I'm going to add whatever that may be. Okay, I'm going to add x. X would be the distance from here to here. Well, that would mean that I need to add x to this as well. And then we could complete this rectangle because, once again, we're making a larger, I believe it said here, a larger parking lot. So that's essentially what it's going to look like. All right. And the new area of the entire thing is going to be 3,300. All right, so we've got to build an equation here. So this entire area of 33,000 should be equal to length times width. That's how you find the area, right? Area is equal to length times width for any rectangle. Well, 33,000 should be equal to, I have x plus 150. That's going to be our new length, and our new width is going to be x plus 110. And then we're going to have to go through and we're going to have to solve this thing. All right, so I have 33,000 is equal to, I'm going to do x times x, that's x squared. X times 110, well, that's going to be plus 110x. And then 150 times x is plus 150x. And then finally, 150 times 110, well, we already have that. That's 16,500. All right. Now, I would like to possibly get, I want to get this equal to 0. So I'm going to subtract 33,000 on each side. I have now 0 is equal to x squared plus, well, I'm going to combine these, so that's going to be 260. and then this is going to be a negative 16,500, all right, 16,500, and we are going to try to attempt to factor this thing. Large numbers, but it might be doable. All right. All right, so after taking a look at this and trying to factor it, you'll notice that this is not factorable. And you could complete the square, although these numbers are going to be quite large, so completing the square would be very difficult. Later on, you will learn something called the quadratic formula in section 14.1. However, what we can do, we have this great tool. You're not going to use it on a test. However, it still is very useful. We are going to graph this, so I have x squared plus 260x minus 16,500. And let's change this window. Let's head over, let's call this x max 0, the x min 0, the x max. How about we go out to, let's say, 70. The y max, I can just go up to, how about 400 for now. Actually, we'll go to 4,000. And let's go ahead and graph this. So you'll notice I have one x-intercept right here. So we want to find that. So second, calculate. And that's going to be number 2. It's a 0. And left bound, that's fine. Let's keep moving over. Here's a right bound. And that happens to be x is now equal to 52.76. So that's the amount. That's the amount that we are going to add on each side here. So this is going to be 52.76, and this is going to be 52.76.